Hello students, this is Professor Shrenik. Today we are going to discuss another usage of potentiometer. In the last video we have already discussed the first use, which is to measure the EMF of unknown cell, for which we can say individual cell method and sum and difference method are the two options which we have. Now today we are going to work on the second application or second usage of potentiometer, is to determine internal resistance of a cell. Now for this, first we need to understand a derivation of formula for internal resistance. So let's say there is a battery along with its internal resistance, and there is an external resistance connected to it. So let's call that point resistance as R. Now these are the 2 points across which we can call this as point A and B. We can say the potential difference between A and B is nothing but the potential difference across the resistance or across the 2 ends of the battery, which also includes internal resistance. For this, if you are aware of the basic formula, that E is equal to V plus IR, where V is the potential difference across the resistance, E is the EMF of the cell, and IR is the potential drop of the internal resistance. Okay. Now if we simplify this, we know I for any circuit where all the resistance are in series, it is nothing but the total EMF of the circuit upon the total resistance, which is R plus small r. Now if I substitute this over here, we get E is equal to V plus ER upon R plus R. Now if I take it on this side and try to simplify it, we get V is equal to E times capital R plus E times small r minus ER upon R plus R. So this ER gets cancelled. So now if I take V in the denominator and all the R terms on the other side, we get E by V as R plus R upon R. Simplifying this, we get 1 plus R by R. So small r by capital R is E by V minus 1. And so small r is nothing but capital R into E by V minus 1. Now this is the formula which we are going to use in this application to find internal resistance of the cell using potentiometer. So if we have a wire AB connected to the battery of EMF E, internal resistance R, a key, and a rheostat of resistance capital R, where these terms are not going to be useful a lot, so I'm just not writing this for time being, as well as to avoid confusion between the terminologies. Here we connect the battery, say E dash, having internal resistance R. Along with that, I connect an external resistance capital R with a key, then to a galvanometer and a jockey. Now if you concentrate that as long as I do not connect this key, this particular circuit is as good as a normal potentiometer, where E dash can be measured using the null point, where R, the small r, will have no effect, because at the null point there is no current flowing through this branch, which results in no potential drop across this internal resistance. And that means I can say E dash can be measured using L1, or you can say the jockey is tapped from point A to B and one point is found for which galvanometer shows 0 or null deflection, and that length from point A is taken as L1. So E dash is measured using L1. Now I connect this capital R into the circuit, and if you concentrate, this becomes the standard circuit which I draw at the start, for which we derived a formula that small r is capital R times E by V minus 1. Do you remember this? Now using this, we can say the point over here for the galvanometer circuit, it is nothing but this point and this end, for which we can say it is the potential difference between these two ends. Correct? For which the jockey can be tapped again from wire A to B. A null point can be found where galvanometer shows zero deflection, and we can measure that length from A as L2, and we can say the potential difference of the entire circuit is measured by L2, and that means E dash by V becomes L1 by L2. So now we can substitute this E by V over here with L1 by L2, and we get the formula for internal resistance as small r equal to capital R into L1 by L2 minus 1. Now here capital R is the known resistance, L1 and L2 is the measured length. We can calculate the internal resistance of the cell. So this is how we calculate the internal resistance of a cell. Again, for this particular thing, there are certain criteria you have to match, that E must be greater than E dash, that goes without saying, and at the same time the polarity of E and E dash connected to point A should be same and not opposite, otherwise you will not get a null point. So I hope you understand the usage of potentiometer. Thank you.